Oh, hey, can I borrow your computer? It will come at a price. Why? Because my computer's dead and I just need one to do some IXL. Well, if you got $19.95, we got a deal. Okay, hold up, wait. Let's check my pockets. Yo, okay, I got 20 bucks. Okay, here we go. We got a deal? Deal. This is yours. I'll take that 20 bucks, but hey, lucky for you, get a nickel back. Here you go. Thanks. Like, I mean, you could have kept the change. A nickel back. The band. Nickelback. Did it ever take a long time to get here? Jeez. I'm ready. Here we go. It's Ethan Rich here, and today I'm going to be talking about linear functions and polynomials. And the two IXL modules that we'll be doing are 9S7 and 9V4. So before we go to lovely IXL and absolutely rage quit, we are going to do some examples just to refresh my memory. Here we go. So basically, we're going to be talking about, here, I'll move it. Just see my face here. That's a little better. Yeah. So we're going to be talking about linear functions. And basically, linear functions, so as you already know, is equal to y equals mx plus b. And so you wouldn't be like this, but like some people are like, oh my gosh, like this is just like the ABCs, like a 2-year-old did the ABCs, they're out of order. No, it actually means something. It means something because it works to this graph. And I'll show you why. So we're gonna go to the left, my left, not yours. So here's, oh, and sorry, this is called a slope-intercept form. This is the best form you can have when you're doing slopes, or the ones that you also want to. So y is just equal to all this, so we're just gonna focus on this part. So m is equal to slope. So the slope is like your rise to the run, your independent to the dependent, your domain to range. It's like they all just mean the same. It's like just having like a blueberry and blue raspberry slippery. They mean the same. It's pretty disappointing. But here we're going to make a slope here. We're just going to put a random line. And basically we're going to find a point. This one, like this is a good point right here. And that point, we are going to do rise over run. So we're going to rise up 1 and over 1. And look at that, we're right on our line again. And if we do it again, rise over 1, rise over 1, rise over 1. So this slope would be 1. And I know it's not incredibly accurate, but for our purposes, yeah. So, and x is just what the slope is getting times by. So really, we don't, yeah, it's just like what this, yeah, you get it. Anyways, and then b is the y-intercept. And as we already know, we've already marked out the y-intercept, which is right here. And it's basically, here I'll have another example here. That's y, here's x, here's a slope, that's our y-intercept. It's when the slope shoots through the y, and that's our intercept. And this is basically all we need to know to complete this IXL. So it shouldn't be that hard, right? Don't need to rage quit, like, really gonna. Anyways. Okay, so let's do it. Okay, so we're going to go to 9S7. Just give me 1 second here. Okay, we're on 9x7. So this, we can clearly see that this, oh, hold up, we can actually move this so you can see it a little better. Sorry, it's gonna be a little, okay, that's, trying to get it where you can see, there you go, there. Okay, so basically, so this slope is clearly going upward, I believe, or is it go, because look at the, yeah, we're going upward, we're definitely going upward here. Okay, so basically, So we're going to use our rise over run techniques. So we're going to be rising up 1, 2, 3, 4, 5, 6, 7 over 1. That's, so basically we're going to, here, let me just write out the thing here. So it's going to be y equals 7/1x, because we always have time at x, minus 1. So let me just let me just get this. 1, 2, 3, 4, 5, 6. Yep. Okay. So, and we're minusing 1. So this should be the answer. Wonderful. Let's go. So let's do one more example here. We are going up once again, and we actually have a point right here that intersects both lines, because we don't want a point in a random spot. We want it right on a line. So we're going to be, let me just do it quick. 1, 2, 3, 4 over 1. So it's 4 over 1 because it's better. Or that's our slope because, or m, 1, 2, 3, 4 over 1. So let's write that out. So put that there. Y equals 4/1. Don't forget the x, because mx right there. X, and our y-intercept is -6. So let me just give it one quick little glance over. 1, 2, 3, 4, 1. So this should be our answer here. Terrific. So now that we've gotten all of our examples out of the way of linear functions, let's move on. Oh, our malfunctions here already. Okay. Let's move on to polynomials. Polynomials, once you see them, you're going to be like, oh my gosh, these are just letters too. But no, there's a little more to them than just letters. So we're going to angle this up so you can see my face really quickly. See it? Okay. So polynomials, very much just about combining like terms. And combining like terms for this one, 9s4, is basically just adding and subtracting. You like and making sure what other types of variables or exponents there are. So let's just do one quick, like, kind of complex example. 7x squared plus 7x squared equals. What would it mean? You know that just like 7 and 7 is 14, right? So why not add them? Because they are like terms. So it's just going to become 14x squared. It is a whole different story when timesing and dividing polynomials, but right now we're just adding like terms. So, and same thing, 3a plus 3a equals 6a. Like, it's just that, it's that simple. But but if they don't have the same variable or exponent value, you cannot add nor subtract. So, surprise, we haven't rage quit yet. We're actually doing decently well. Go to, and sorry, I'm just going to take a second here. Just give me a second. You can look at the example on the whiteboard while I find 9v7, which is, 9v7, sorry, 9v7, my bad. 9v4. Yeah, 9v4. That's what we're looking at. Okay, so here's our example. It is 6u plus 4. And again, these ones are not, well, like we did some complex ones. There are going to be complex ones, but this one isn't that bad. So 6u plus 4, there in brackets, plus 2u plus 5. They're all positive. This is really straightforward. This is going to be 8u plus 9. It's just that. It's like, and I'll tell you why. 8u, let me just get the plus sign, plus 9. Terrific. And, oh, here's a bit more of a complex example. You see this? So I'm actually going to do it really quickly, and I'll show you after why. So, and I'll kind of talk through it. So basically, on my screen, I see a 2q squared. And 2q squared is the only squared number. So 2q squared can go straight up in our thing, because you can't add or subtract to it. And now we're going to be going... Now we're going to add, because it's all positive again. So 4q, I see a 4q and a 6q. Add them together. I'm assuming you said the answer, but 10q, yeah, okay. 10q, and then you add this again. 5 plus 3, 8, great, there you go, 8. And there you go. So that should be our answer. Excellent. That was all you. Great job. So now that we did 2 examples from linear functions and 2 examples from polynomials, we are going to do one more example, because polynomials seems pretty easy. We're going to do one more example from linear functions, and let's knock it out of the park. Let's go. Here we go. Let me just go back and find it, because we came so far, we can't mess it up now. Let's do it. Where's 9s7? We came so far, we can't mess this up now. Let's go back, let's erase this. Remember slope-intercept form, y equals mx plus b. And this one already, negative slope. Sorry, you can't even see it. Negative slope. And so we know it's going to be negative. So let me write down y equals, so I have to write negative or else I'm definitely going to mess it up. So I already see, remember, y-intercept. Pretend this is a y-axis, or here's the y-axis, here's the x. This would be our slope-intercept, or slope-intercept, sorry, that would be our y-intercept. And, sorry about that, that was on me. But in this one, our y-intercept's 2, but we're going to get to that. So since it's negative, we're going to be going down 1, and we're going to be going, so we're going to rise down, so negative, so whatever, lower down 1. It looks like we can get to a point here. So 1, 2, 3, 4, 5, 6, 7, 8, and we're running 8. So it's going to be negative 1/8 x, because y equals mx plus b, as you already knew. Shift adding 2. So this should be our answer, because I'll explain one last time. 2 goes, so basically we're rising down 1, and it goes 1, 2, 3, 4, 5, 6, 7, or sorry, is that 1, 2, 3, 4, 5, 6, 7, 8? No, I was right, 8. So we're going over 8, and we're adding 2. This should be your answer. Fantastic. So, Mr. Bauer, thank you very much for watching this video. I hope you learned something. Well, I mean, I hope I taught you something today. And, you know, I think it's time to go give, he didn't really need to give me the change. I think it's time to go give that guy at the shop his nickel back.